Today we are going to utilize our skill of finding the volume of rectangular prisms to find the volume of shapes that are not exactly a rectangular prism. So just to review, our rectangular prism here is length times width times height, or in some cases we know the area of the base and we do the area of the base times the height, because obviously it's created by length times width. So if you have a pyramid, do my best to even just a prism like that, a triangular prism, this volume formula will not work. If we have a sphere, which I'm not even going to attempt to draw a sphere, it does not work. If we have a shape, that resembles a rectangular prism, we still can't use the formula, but similar to shapes that were not exactly a rectangle, we could split this into a rectangular prism and another rectangular prism, find the volumes separately, length, I guess that would be more height, and that would be our width in there, and then we would again add our two volumes together. So we're going to do what we've done in the past in terms of finding area of these shapes. We're just applying our volume formula, and we're going to do so in a manner that gives us rectangular prisms. This first model here is a great start because we can very clearly see it almost looks like two separate shapes. But this is one shape, it is connected, but we can use this formula that we know to find the volume. So if we look at our first shape that I'm going to highlight here in green, we have a rectangular prism that is going to extend down here as well. We have a length, a width, and a height. And so we can do 11 times 6 times 4, and that gives us 264. If we look at our other prism that we can create, it's this one in the front here, and we have 3, 4, and 5, which gives us 60, and if we add those together, we get a total volume of 324 cubic inches. And so again, we are just identifying and isolating the rectangular prisms to be able to find those volumes and combine them in the end. So take a minute, if you have not already, to copy down this shape and the work attached. If you did not pause, go ahead and do that now, because I'm going to move on to the next example. So here, I want you to take a minute to copy down the shape, and I want you to first just divide it into two rectangular prisms and see if you can start to identify the measurements associated with it. If you have not already, please pause the video now to do that. So there's a couple ways that we could divide this. I could cut across here, and that would create a bottom rectangular prism and a top rectangular prism, or I could cut it down here and it would create this kind of front portion and then this back portion. There's no right or wrong reason, no right or wrong way. I'm going to just cut it across, and I'm going to cut it across back here as well. It definitely gets a little bit more tricky when we're looking at these 3D shapes, trying to identify all of the sides. But you can imagine here this is a larger box on the bottom, and then we have a smaller box stacked on top. I really like to picture it as Amazon boxes that are delivered to my house. It's something that happens so frequently. So I can really look at, it's a lower box and an upper box. So looking at my blue shape, I need to try to find length, width, and height. The biggest key to knowing you've found those three, is they should not be parallel. If lines are parallel, it means they are representing similar lengths, similar sides. So they're both a length, or they're both a width, or they're both a height. So you really want to make sure that the three lines end up not being parallel. So kind of similar to this. You can see I have one going down, diagonal, and straight across. So they should not be parallel lines. When looking at the blue, I can quickly see here, I have one line going this direction. I have one line going this direction. And then I have one line going this direction. So I have three lines that are not moving in parallel. This one here has the 8. This one has the 8. This one here has this 9, but you can see that's applying to this whole side. So that 9 is definitely not going to be what I'm looking for. I can find another blue line moving parallel. Right here, I have no information. Right here, I have the 5. So for my larger box, 5 by 8 by 8. That gives us 320. And now I want you to pause the video and analyze the green box. Where are those three lines that are not parallel that I can use as my measurements? Go ahead and pause the video now so that you can identify those measurements. So here I have one moving across, one moving up and down, and one going in that kind of diagonal direction. So my height here, I don't have a measurement, but if I move to the next parallel line to that, I have a 4. So that's going to be 4. Looking at the diagonal line, again, I have no measurement here. I can follow it to a parallel line here, no measurement. Parallel line here, no measurement. Parallel line here, no measurement. Parallel line here, I have that 8. So again, you can see that once I've identified the three directions, I search parallel lines to find that measurement. And we've identified the 8. Lastly, I'm going to look at this line here. And here I have a parallel 8. But we need to be very careful and look. The 8 is representing this full length, longer than our green box. I have a 2 here and an 8 here, which is going to leave 6 for that measurement. So I have 8 times 6 times 4, and that gives us 192. So I can add the 2 together. And that gives us 512 cubic inches. So for our last problem here, please take the time to copy the shape, copy the measurements, split it into some rectangular prisms, and do your best to find the volume. If you get stuck, unpause the video and follow along with my instruction. But otherwise, solve it all the way and then unpause it to watch my instruction and check your work. I'm going to start solving now, so make sure you have paused your video. I'm going to divide my prism lengthwise like this. Visually, that's just what appealed to me. It doesn't have to be the same for you. You should really do what you see first, because either way it's going to work out to the same answer. And my green box. So now, again, picturing those Amazon boxes, I have kind of two tall and skinny boxes. One is standing upright, and the other is slid next to it laying down. And again, I'm getting that visual in my brain to really help me work through and solve this. So it looks like I have a lot more information for my green box here, so I'm going to work with that first. I can see that I have one line up and down, one line kind of diagonal, and then my straight across. So I have the 3 here, the 2 there, and the 12 is this full length. So that's not going to work for me. It's a little bit messy because I kind of scrolled over this, but this 8 is applying to this full length back here. So I can go with the 8. So I have 8 times 3 times 2. And that is going to give us 48. It's a little bit sloppy, so I'm just going to write it again so I don't forget. So for my blue rectangular prism, here's my one direction up and down, side to side, and diagonally backwards. So I know that my up and down here, I have the 10. This diagonally back, I don't have a measurement here, but again, using my parallel lines, work one to the side, and I have the 2 there that we used in the previous one. And my last one here, I have the 12, and I know I already had 8 for this portion, so that's going to leave 4 here. Again, I think one of the keys here is finding those 3 directions, up and down, side to side, and this kind of diagonal. Looking for 3 non-parallel sides. Once you've identified them, then you can follow parallel lines to find the right measurement for what you're looking for. So last step, I will add these together, and it gives me 128 millimeters cubed, or cubic millimeters. So we're really just using the formula you always know, but creating rectangular prisms to use that formula.